In this video we are going to look at an introduction to graphing an ellipse, and in order to understand how to graph an ellipse it's very important to understand and know the basic equation of an ellipse. Now this equation right here is if an ellipse is centered at the origin. So it's going to have a center at 0, 0. There's a more complicated formula that you'll learn soon that involves moving the center of the ellipse, which you can kind of see from these general diagrams is at 0, 0 here. It's centered top up and down at the origin and left and right. Its center is right there at 0, 0. If I wanted to shift that, I'd have to alter this equation slightly. So this equation is only for ellipses that are centered at the origin. You know, let's put the equation up here if it's not centered at the origin, just so you can see. And I'm not going to go over an example of these in this video, but it's not too much different than what we have for an ellipse centered at the origin. Right? Can you see what's different there? Hopefully you're noticing the only thing that's different, instead of x squared, we have x minus h squared, and instead of y squared, we have y minus k squared. And what that'll do is move the center to h and k. And that'll mean more after we're done with this video about finding the center and doing your graph from that center. But it's not that much more complicated when you get to those kind of problems. All right, so let's look at the formula. Let's look at the formula again. Oops, I want to delete this. Let's see here. Let's get rid of that. Okay, we have x squared over a squared plus y squared over b squared equals 1. Now the x and y are going to represent your points on the ellipse, and the a and b are shown here in these pictures. So the a value, which is always going to be underneath the x squared, is going to be this distance from your center out to what we call the major axis out here. In this case, this is the major axis because it's the longest axis. And this is going to be your a value as well. And then whatever's underneath your y is going to be how far up and down you go from the center. So it's under the y. The way that I remember the up and down is because the y-axis runs up and down. So wherever your center is, you're going to find your b value and go up that far and make a dot, down that far and make a dot. Same thing with the x. You're going to find your a value and you're going to go right that far and make a dot, and left that far and make a dot. Okay, now if your a value is bigger than your b value, your ellipse is going to look like this. If your a value is smaller than your b value, your ellipse is going to look, you know, elongated on the vertical. It's going to look like this. All right, so a and b, one doesn't have to be necessarily bigger than the other one. All right, now another key feature about the equation of ellipse is it has to be equal to 1. It has to be equal to 1, and that's important. You kind of think about other equations that you know, like the equation for a line, y equals mx plus b. If we're going to talk about characteristics of a line, we know b is the y-intercept and m is the slope, but we can only find those things if it's solved for y. That's the same idea. This has to be equal to 1 in order for us to determine a and b. If it's already to equal to 1, like the first example we're going to do, then great, we can just start graphing. But if not, we have to set it equal to 1. Okay, so let's look at an example. Let's get rid of these general pictures here and bring in a basic example. We'll put this underneath the equation so we can see how that works. Alright, so in looking at this example, we see that it's already equal to 1, so that's good. Okay, now what's in the a squared spot, let's call it. All right, here's my a squared spot, which is underneath my x. What's there? I have a 25 there. So therefore a squared is 25. And then what would a be? What squared is 25? That's 5. Good. Okay, so now we'll find our b value. So our b squared is always underneath your y squared. So that's the 9. So that means your b squared value is 9. Then what's your b value? Well, what squared is 9? That would be 3. You take the square root of 9, you get 3. Okay, so we know our center is at 0, 0. Now that's not a point on the ellipse, so you don't really want to make a point there. but we know that's going to be our starting point, starting from the center. So our a value is 5, which is under the x. That means we're going to go on the x-axis, we're going to go 5 to the right and make a point, and 5 to the left and make a point. Then our b value is going to be up and down from the center. So from the center we go up 3 on the y-axis, since that's underneath the y value, and down 3 and make a dot right there. Now this gives us the general outline of the ellipse. This is going to be a challenge here. Let's see how I can do. That's pretty good. Oh, it got a little bit yucky there. Let's see if I can make that better. Kind of got away from me right there. Now if you want to find more points so you can draw a prettier ellipse than what I'm drawing right here, you would have to actually plug in values of x and y, plug in values of x and solve for y, or plug in values of y and solve for x, which you could do. But if you're just asked to graph a general shape of an ellipse, this is good. This is fine. Just find your major axis endpoints and your minor axis endpoints, and you can sort of sketch in the rest as best you can. Okay, let's look at one more example where it's not equal to 1 and see how we can make that happen. Now first of all, I'm looking at this equation. If I didn't know it was an ellipse and it just said graph, the first thing I would want to notice is it has an x squared and a y squared. Probably the stuff that you've learned how to graph is a line. Alright, we know this isn't a line because lines don't have x squareds and y squareds. Then the next thing you learned how to graph was a parabola, most likely. And parabolas either have just the x squared or just the y squared. So a parabola would have the x squared and then a y, or a y squared and then an x. It's not going to have both of them squared. When you have both of them squared, both your x squared and your y squared, you're looking at 3 possibilities. You're looking at a circle, an ellipse, or a hyperbola. Hyperbola. Now a circle and ellipse, they're both going to have positive coefficients on their x squareds, which is what we have here. And a hyperbola is going to have 1 positive coefficient and 1 negative coefficient on your squared terms. So that's a little bit beyond the scope of this video, but it's kind of a good thing to think about. You know, how do I know this is an ellipse? Well, it's going to, if I can, another way to think of it too is if I can put it in this form, then it's going to make an ellipse. But probably if you're studying ellipses, you're also studying circles and hyperbolas, and so you want to keep in mind how to distinguish between the 3 of them. And you could kind of think of an ellipse as a squished circle. You could, if I had a circle, my a squared and my b squared would be the same number, and that would actually end up being your radius, your r squared. Okay, let's get back to our ellipse here and think about how we can put it in the proper form. So we need it to be equal to 1. I need this to not be here, this 196. I want that to be 1. Well, how could I make that a 1? And put it in this form. Notice I have an x squared over an a squared, so I want this 49 to be over something. Some of you might be thinking, well, I could minus 195, that would make it 1. And then I'd have to minus 195 from this side. That would give me a 1 on the right side, but on the left side, I wouldn't have anything that looks like this. I need just an x squared over an a squared. So actually, I don't want this 49 or this 4 here either. So I need to get rid of all my coefficients. So most of the time on a beginning problem, if you just focus on making the 196 into a 1 by dividing, it's going to work out here on the other side. Let's see if it does. So in order to make this a 1, I'm going to have to divide by 196. So if I divide by 196 on the right, I have to divide by 196 on the left-hand side. I could divide the whole thing by 196, which is the same as dividing each term by 196, which I'm going to write that way. And the reason I'm doing that is because I'm trying to make it look like my form up here. And I want them split up. Now, as I said in these beginning examples, it usually works out pretty nicely, and in this case it does as well, because 49 goes into 196 exactly 4 times, and 4 goes into 196 49 times. So let's see what we have now after dividing. We have x squared over 4 plus y squared over 49 equals 1. All right, that looks good. We look like our form of an ellipse here, and we can now determine our a value and our b value. So what's in the a squared spot is 4. Now this is important. A is not 4. A squared is 4. So remember, you're always going to take the square root of what's underneath the x value in order to determine how far left and right you want to go. And then your b squared value is 49. You're probably not going to be tempted to go up 49 and down 49, but the 4 is a little more tempting. Take the square root of that and we get 7. So see how this all worked out nicely, gave us perfect squares, and it's going to make it easy to graph. If this wasn't a perfect square, you'd have to estimate it, but most of the time they make it come out nice, but sometimes they don't. So if you were graphing and you got a weird square root, you'd have to put it in a decimal and then estimate to the nearest tenth or whatever they want. Okay, so let's graph this thing. Now, in this case, our a value is smaller than our b value, so we're going to have an ellipse that looks more tall. Again, this is centered at 0, 0. So we're going to start at 0, 0. Our a value is 2 under the x, so we're going to go 2 to the right, make a dot, 2 to the left, make a dot. Our b value is 7, which is under the y, so we're going to go up 7 on the y and down 7. And that gives us our general form of our ellipse, and then we just do the best we can to make this look nice. Oh, that got a little fat down there. That's tough to do. Well, you get the idea. I could erase it and make it look nice, but then it's going to erase my actual graph lines. That's a little better. Okay, it's not perfect, but you get the idea. That gives you the general shape of an ellipse. So again, the important parts are to memorize this equation, to know this equation. If you get into ellipses that are not centered at 0, 0, you're going to have to memorize that other equation with the x minus h squared and the y minus k squared. And then you'll just shift your center over and do up and down and left and right from that new center. But it's all these ideas are still going to hold true if the center is not at 0, 0.